Welcome to Exploratory Data Analysis, the missing ingredient in marketing AI. My name is Christopher Penn, co-founder and chief data scientist at TrustInsights.ai. Marketing right now, marketing AI in specific, has a problem. That's a really big problem. The really big problem is lack of adoption. When we look at the 2022 CMO survey, which is a survey run by Duke University to chief marketing officers all over the world, they were asked, what investments did your company make to improve the performance of your digital marketing activities over the last year? When we look at machine learning and automation, artificial intelligence, 26.4% of CMOs said they made some kind of investment in machine learning in the last year, which is an increase of 29% from the previous year's survey. But it's still not really widely used. People are still not reaping the benefits of artificial intelligence. Again, when we dig into where CMOs think they can improve, we see that advanced measurement, including artificial intelligence and machine learning, as well as attribution, mixed modeling, etc. Only 28.5% of CMOs say they are currently doing that today in their marketing. When asked what kind of use, to what extent is your company using artificial intelligence in optimizing and automating marketing efforts, only 11.8% of CMOs said AI specifically. Remember, we had a bunch of things lumped in together. AI specifically, only 11%, with 37% saying they plan to in the next 3 years. The challenge with this number, of course, is that CMOs are usually a little over-optimistic when it comes to what kind of actual investment they will make down the road. Which leads us to the question, why is this number so low? Why is artificial intelligence not being used more by companies? There's a few different reasons for this, but to dig into those reasons and illustrate them, maybe in a little more of a down-to-earth format, let's get away from thinking about artificial intelligence as this super intimidating, super complicated technology, and maybe think of it mentally as just like a kitchen appliance, right? If you're cooking, you have appliances in the kitchen. Maybe. Most people do have some kind of appliances, a stove or something like that. And appliances are pretty much black boxes in a lot of ways, right? You don't really need to know the inner workings of a blender or a microwave to know that it's supposed to do a certain task and that you put things in and you get things out of it. With artificial intelligence, one of the reasons why adoption is so low is that there's a lot of promises being made by vendors. And in many cases, the technology doesn't really live up to those promises, not as well as you might think on the sales material. A lot of the time, artificial intelligence technologies are misunderstood. The purpose of them, what they're supposed to do, what you're supposed to do with the technology is misunderstood, right? It's like using a blender as a knife holder. Right? It's not really what that intended purpose of that appliance is. Artificial intelligence, in a lot of cases, people don't understand even the broadest strokes of how it does its thing, right? The mechanics of it. What do the different pieces and components of AI do? Right? Again, akin to just not understanding how blenders work at all. Many times, there's a misunderstanding about the process, order in which you do things in artificial intelligence, right? It's like putting a prepared soup in a blender instead of using the blender to prepare soup. It's just a mistaken order of operations. But the biggest one that throws off a lot of companies is misunderstanding the ingredients that go into artificial intelligence, putting one thing in and expecting something else to come out, right? It'd be like putting water in a blender and expecting it to turn into, chicken noodle soup. Well, if you don't put the other ingredients in, it's not going to happen. So what is that ingredient and why is it so important as to AI being held back at companies? Let's do an analogy. And for those of you who remember grade school, these are the analogies that were on a lot of those standardized tests we did. Data is to AI as ingredients are to cooking. Data is to AI as ingredients are to cooking. Once we understand that, we can start to understand why so many AI efforts fail. Because the ingredients we're putting in, maybe they're the wrong ingredients. Maybe they're spoiled ingredients. Maybe there's not enough of the ingredient. We understand that the machine won't turn out good results, right? Imagine putting a teaspoon of water in a blender. It's insufficient. The tool's not going to be able to do its job with just a teaspoon of water. Imagine putting sand in a blender and expecting to get wheat flour out of it. That's not going to happen. Imagine putting in rotten produce and expecting a fresh smoothie to come out of it. Again, not going to happen. Data is to AI as ingredients are to cooking. And if we understand that, then we know that we've got to make sure that our ingredients are good if we want to have any hope of creating a good output. Because no matter how talented a chef you are, no matter how expensive your appliances are, no matter how elaborate your menu is, if your ingredients are bad, you're making bad food. Right? And the same is true of AI. So how do we fix this problem? Well, we fix this problem with a technique, really an entire discipline, called exploratory data analysis, EDA. What is exploratory data analysis? IBM has a great quote. Exploratory data analysis is used by scientists to analyze and investigate data sets and summarize the main characteristics of often employing data visualization methods. This is the key part. The main purpose of EDA is to look at data before making any assumptions. The main purpose of exploratory data analysis is to look at data before making any assumptions. And we can see this process play out in a very common sense way. Imagine you're about to make dinner and you announce you're going to make steak for dinner, right? Are you? Maybe you're not, right? That's sort of putting things out of order. What you probably should do is look in the refrigerator first and see what ingredients you have and if they're any good before announcing your grand dinner plans. Because if you yell out to everybody, hey, we're making steak, and you've got no steak, you're not making steak, right? So you look in the refrigerator, you see what's all is in there, and then you go, you know what? Okay, we can't make steak because we don't have any, but we do have the ingredients to make a decent chicken noodle soup. So let's make a chicken noodle soup instead, right? The analogy extends to AI. You may want to have some elaborate AI model, but if your data doesn't support it, you might choose a different kind of model, a different kind of analysis, a different kind of outcome that fits the data that you have and the condition that it's in. Now, the corollary is the explanation about why AI projects skip EDA. And we talked about this is the missing step, the missing ingredient. A lot of AI projects skip exploratory data analysis for a couple of reasons. One, it's very time consuming to do it well. Two, it requires skill sets that are in some cases somewhat different than creating artificial intelligence models themselves, especially if you have somebody who is not classically trained in things like statistics and probability, linear algebra, calculus, etc. If you have somebody who's just a pure coder, no disparagement intended, but a coder who doesn't have the mathematical background to be doing AI is going to create bad AI. But most of all, the reason why AI projects skip exploratory data analysis is because somebody somewhere said, hey, we're making steak. And then you kind of have to cobble that together. And you skip the exploratory data analysis process. You skip the ingredients because the decision has been made somewhere else in the chain of events leading up to your project, even if you don't have the ingredients to support it, which is also the reason why so many AI projects fail, because somebody said, we're making steak, and there's not a stitch of beef anywhere in your house. Okay, the AI equivalent of that. So what is this? How do we bring this exploratory data analysis process to life? How do we show it in a practical way? We're going to stick a little bit with the cooking analogy, but then get into the actual technology. And as a precursor here, we're going to be showing a lot of code and stuff, but you don't need to code. You just have to have somebody on your team who can build in the appropriate technologies to do exploratory data analysis. And some of it can be done even without coding tools, but some of it you really do need to be doing some code stuff. So remember, this is all about understanding our ingredients, right? We want to look in the fridge, look in the pantry, and make decisions based on what we find in there, right? You might look in the fridge and say, hey, we got potatoes, but they're all rotten. So, okay, we're not going to make French fries. This is the exploratory data analysis process. It's a 8-step process where you set your goals and strategy, you do data collection, attribute classification, initial analysis, requirements verification, data preparation, feature engineering, and then hand it off for modeling or insights. That's the exploratory data analysis process. And we're going to step through each of these stages in detail so that you can see them brought to life. The first step in exploratory data analysis is your goal and strategy. This step answers the question, what are we doing? And maybe even why are we doing it? For exploratory data analysis, one of the most valuable tools that you can use is called the user story. The user story is a very simple statement. It's a single sentence. As a, whatever your role is, I need to, the task you're trying to accomplish, so that there's some kind of outcome, right? As a, I need to, so that. And we're going to write out a user statement for your exploratory data analysis, for what the purpose of the project is. Let's look at a concrete example. As a content marketer, I need to know what makes digital marketing articles do well so that I can create a great performing article. This tells us a lot about the kind of data we're going to need. Right? It tells us an awful lot about what kinds of data we should be processing. It's going to be content. It's going to be digital marketing articles, so article content. And the intended outcome is for that article to perform well. So we know that we need to go and get data that fits those requirements, which brings us to the second step, the data collection. Where are we going to get our data? Well, if we think about that user statement as a, I need to, so that, and we have these content marketing things, we know we would want to go maybe to an SEO tool and get that data from there. So here's an example of one SEO tool. This is the Ahrefs SEO tool. And we're looking for articles about marketing and artificial intelligence and machine learning and digital marketing and stuff. So all sorts of data that fits this user statement. I need to know what makes digital marketing articles do well. So we have some of these metrics like page traffic, referring domains, etc. So we've got our data. We've answered the question, where do we get our data? Our next step in the process is attribute classification. And that sounds super fancy, but all we're really doing is answering the question, what does the raw data look like? Right? When we load it in the analysis tool of our choice, what's in the box? Right? We can look and see the what article number it is, the content title, the content URL, the author of the article, the domain rating, traffic, Twitter likes, Pinterest shares, the number of words in the article, and so on and so forth. Part of exploratory data analysis is, again, just looking at all of the different options and seeing what they are. We might want to look, for example, and see what types of data these are. Some of these are numbers. Some of these are characters. Some of these are dates. Right? So knowing these things helps us understand better what data is available to us. We also might want to look at just some of the basics of like what's in there. Do we have, how many things are continuous columns, meaning numbers? How many are discrete, meaning not numbers? How many places do we have missing data even? How many things do we have missing columns? This is part of exploratory data analysis. Just think about this as like the nutrition label on an ingredient, right? So you pick up an ingredient, you look at the nutrition label. When you do this first phase of exploratory data analysis, this is really just looking at the labels on our data. And we want to do this. We want to understand this in order to be able to match up our user statement. So here, based on what we found in our data, right? We found things like traffic, for example, or traffic value. We now know we have a performance measure. Instead of saying, I need to know what articles do well, I can say a specific metrics. I need to know what makes digital marketing articles earn traffic so I can create a great performing article. So we've used this stage to identify, can the data start to answer our question? From there, we go into our initial analysis. We look at things like univariate, multivariate, data quality, anomaly detection. And really, this stage is all about answering the question, how good is the data? What's the quality of the ingredients, right? You open the refrigerator, you open the produce drawer, and you get some carrots, and they're covered in mold. Ooh, that's not very good. Same is true with our data. We open our data up, we look at it, and we say, okay, how much data is good or bad, or just there's just not enough of it? And so any good exploratory data analysis tool can produce these kinds of results, and just look at the data and say, okay, a lot of these fields are labeled green, meaning they are usable data. Some of these fields, the ones in red, yeah, there's not either not enough data or it's in bad condition, and some of it there's just so little data that we might just be better off maybe removing those fields. Maybe. We would want to do some univariate analysis, looking at distributions. Are there unusual patterns or anomalies sticking out in the data? We see, for example, number, which is the number of article. That's not a particularly helpful field, right? That doesn't really lend any insights, just the numbering of the article. The HTTP code, which is the response from the servers when these articles are being scanned. Again, that's not really helpful, right? So we're already getting a sense of there's some data in here that's maybe good, some data in here that's really not good. We might want to look at it even more categorically, get a sense of what averages or medians are involved in the data, trying to understand all the different fields. We have, for example, 79 articles that have no titles. We have 146,000 articles where there's no author. Like, wow, there's a lot of issues in this data set. We might even want to try and get a sense of what are some of the words and phrases, because there is text in this data set. So we want to explore that and see very quickly what are some of the common phrases in these marketing technology articles, things like software reviews or Google Analytics or artificial intelligence. Again, this is one of those things, this is basic quality check. If I saw a whole bunch of terms in here that were like, first baseman or banking ideas or coupon codes, that would tell me that the quality of the data is not very good, right? The ingredients, what we think is in the box is what is not actually in the box. So this step is very important. It is also a step that, again, people tend to skip, especially in big machine learning projects where you are maybe training large language models or training large vision models, or even doing large-scale regression analysis. You might have a lot of junk in those articles. You might have a lot of stuff where, it's just not very good. Once we've done our initial analysis, we want to do our requirements verification. We want to ask, does the data answer the question? And we found that there is enough data in here about articles, and there's a response variable, an outcome variable, traffic, that can help us answer the question. So the answer in this case is, while there are issues in the data, they're not insurmountable. If traffic wasn't in there, for example, we might say, you know what? We can't answer this question, right? There's no outcome, and therefore there's really nothing to find. And so we would have to, at that point, start the process over, either with a better question that fits the data we have, or get better data that can answer the question. But we can verify at this step in the project that the requirements have been met. Our next step is preparing the data, tasks like centering and scaling and cleaning. And this is really about how can we ready the data? How can we get the data ready to be used in some kind of either more advanced analysis or AI project? And again, we want to look at those fields where, okay, there's some things in here that are just not going to be helpful, like the language variable. There's so much of it missing that it's probably not going to be very helpful. Platforms, 82% of the articles have platforms not specified. There's probably not a lot of predictive value. We saw in the univariate histograms, things like article number, not very helpful. So this is an opportunity for us to start knocking out some of the fields where there's little to no predictive value. There's not going to be any insight garnered from those things, so we can start removing them. We can also start applying mathematical transformations as well. Once we've done that prep, now we have to do feature engineering. This is about either extracting or adding or removing even more from our data set. And this really is about answering the question, what do we need that we don't have? And what do we get rid of that our previous steps have indicated, yeah, there's a lot of issues. So we might, for example, want to transform some text things into numbers or other fields. In this example, we're taking the title of an article and spinning up, like, what is the length of the title? Is it a short title? Is it a long title? Counting the number of characters in the title. Counting how long the URL is or how complex the URL is. If you think about it, if you have, TrustInsights.ai /blog/2022/18 that's a very long, complex article URL. We might want to see if complexity of URLs makes a difference as to the popularity. We might want to decompose things like our dates into hour of day or day of week. We might want to, from our URLs, expose the domain name or the domain extension, for example, like a .com, .org. We saw that Republished didn't have a lot of data, but there were some republished articles. So we might want to transform that into a simple, logical variable, like, is this a republished article, yes or no? So if it is republished, if there's a republished date, we've specified it's a 1. If there isn't, a 0. And so this kind of feature engineering is adding to the data set, adding more stuff in based on the data that's already there. We're also doing some removal of some really simple stuff, like, any column that's empty, get rid of it. That's not going to be very helpful. We want to filter for articles that have traffic, right? If that's our outcome, we want to make sure that we're calibrating on that. We also want to take a look at some of the features. For example, domain names. There's 12,000 domain names, different domain names in this data set. That's going to be very, very hard to model, almost impossible. You would need so much computational power, and it might or might not yield anything useful. But we could see, for example, the suffixes. There's only 260 suffixes like .org, .com, etc. That's much more manageable for doing any kind of analysis. We also might want to reduce the number of features. When you extend out all the different features, like the extension, the domain name extensions and things, you're going to have about 309 columns in this data set. Again, if we're trying to do some regression analysis, that's going to be really, really computationally intensive to try and pull that off. We might be much better off taking the most statistically significant variables, if we can identify them up front, and use those. We sort of slim down the number. Here, we're using a type of correlation called Spearman correlation and saying, of all the numeric variables, which ones have the strongest correlation, positive or negative, to our outcome, to traffic? Right? If we run that analysis, we can identify those columns. Then there's a whole bunch of columns in the middle that are not on this chart, about 270. They don't have any mathematical correlation. They probably have no predictive power, so it's safe to get rid of them. This feature engineering step goes through a lot of different parts that a good data scientist or a good data science person on an AI team can help make your data usable for AI, right? If we just naively threw all the data in as is, we would not get a very particularly useful analysis. We would get stuff that, frankly, was a lot of garbage, a lot of noise. And this is what sets apart a good AI team and a good AI project from a bad one, by being very selective in the data that we use, cleaning it well, preparing it, doing a lot of feature engineering. Everything up to this point in your average AI project is about 80% of the total project length, because there is so much complexity to doing things like feature engineering, to identifying which variables do and don't matter. Again, this is like looking at everything in your refrigerator, right, and then narrowing down, well, if we want to make chicken noodle soup, do we really need to be considering this bottle of orange juice? Probably not, right? Do we really need to be considering this bottle of fish oil? Maybe. What about this pile of apples? Again, probably not. We're winnowing down our ingredients to the ingredients that matter the most for a chicken soup. And the same thing is true in the feature engineering set. And then taking those features Like maybe we find some onions in our refrigerator. Do you put the whole onion in the soup pot? Probably not. You probably take it out, chop it up, and prepare it so that it works better in the soup. And the same thing is true in our data. We took some features of our data, like the date, chopped them up into hours of day and day of week to make it easier for our algorithms to digest. This brings us to the last stage in the exploratory data analysis process, which is the actual modeling. And it's outside the scope of today's talk to talk about, which models and things like that. That's part of the AI life cycle. But the exploratory data analysis process effectively ends here. We hand off of this nicely clean engineered data set to the AI process to now create some results, right? And if you're curious, what are the results? We used, in this case, the XGBoost algorithm to model our engineered data set. And the answer it came up with was that in terms of things that predict traffic really well, by far, and the only result that's really statistically significant is the number of referring domains. So if we think back to our user story, as a content marketer, I need to know what makes digital marketing articles earn traffic so I can create a great performing article. Well, our analysis now says, hey, your article needs referring domains. It needs links from other sites, lots of them, in order to create traffic, which again makes logical sense. If you get your article linked up all over the place and it's driving traffic to your site and improving your SEO, of course, you're going to earn traffic on your article. There are other factors here like URL length or website traffic or title length, but these have very weak signals. These don't have a good indicator that there's a there. And so we shouldn't rely on them in our analysis. We can instead hand off, though, to a content marketing team. Hey, once you've got your content, you've got to go out and get links for it. If you want it to do well, if you want it to get traffic, this is what matters. So how do you get started doing exploratory data analysis? Well, the most important part is what you're doing right now. By watching and listening and understanding the process itself, you know what to expect. You know the steps that should be taken. As a marketer or as a stakeholder, when you work with your data science team and your AI team, you can question them about each of the 8 stages of the exploratory data analysis process and ask them what steps they took, what things they did to prepare the data for machine learning and artificial intelligence. And if the answer is, we don't need to do these things, you might want to maybe consider adding some new staff with some fresh insights and more rigorous adherence to best practices to your AI process. Because if you don't do these things, you skip over exploratory data analysis, you will effectively be cooking with ingredients that you don't know the quality of. And it might turn out okay. It might also kill a bunch of people, right? So you want to make sure that you're cooking with good stuff. Now, people ask, what about tools? There are lots of tools that can do things like automated data preparation, right? That's a really popular term right now in the AI and data science world. That's kind of like buying pre-packaged ingredients, right? So you can be pretty sure that the bag of frozen vegetables here, probably not rotten, right? But is it prepared the way that you want it to for the applications you have in mind, right? If you're making fajitas, I will tell you, this bag, the vegetables that come out of it are really, really watery and limp, right? If you want that satisfying crunch when you're making a good fajita, this bag is not going to do the job for you, right? It's the same is true of data prep. Can you get automated tools to do some of this data prep? Yes, you can. Will they do as good a job? Probably not. Right, probably not, because there are decisions that we made along the way in the process that required our subject matter expertise as marketers to know, okay, that variable really doesn't matter, right? From simple things like removing the article number to more complicated questions like, does the platform that an article is published on matter? A lot of these tools will ingest all this data very naively and will use only statistical criteria to knock out certain variables, and will not necessarily have any subject matter expertise to make those decisions more nuanced. There was another example, republish date. We saw 91% of the data wasn't there because 91% of the articles weren't republished. If you were to use an automated tool you would probably get rid of that field. And then you wouldn't know to transform it into that logical field, right? Yes, it's republished. No, it's not republished, as a way of making a decision. Now, did that show up in our final analysis? No, because it did not have a correlation to our target outcome. But you can certainly imagine there might be a situation where it would. And the tool in this case would have made a decision that to eliminate that variable, and it really shouldn't have. Then you get into things like, well, maybe we can just automate the machine learning process entirely, right? There's all these auto ML tools out there. They must really know what they're doing, right? Again, that's the equivalent of getting a prepackaged meal, right? It's been done for you, top to bottom. All you get is the result. But is it made the way you would have made it? Are the ingredients as good as the ones you would have bought and prepared yourself? Is the process been followed to adhere to any unique dietary restrictions you have, and so on and so forth? The same thing is true of AI. A big question that you have to ask yourself as you embark on using machine learning and using artificial intelligence is whether or not you're using it just for finding efficiencies or whether it's part of your core competency. If artificial intelligence is a part and parcel of your secret sauce, you probably want to do the exploratory data analysis the way we've shown here, step by step, crafted by hand, because the future of your company may rely on it, and you want to make sure the analysis is done right and as well as can be. If you're using AI or machine learning to automate something that's not mission critical, that's not part of your secret sauce, then yeah, you might want to say, let's get an off-the-shelf product that will do the job, maybe not as well as we would have done it. Maybe not the output won't be as good as we would have made, but it's good in a pinch, right? And because it's not your core competency, it's not going to dramatically impact your company's productivity or your revenue if things go sideways with a prepackaged product. So, we have covered the spectrum of exploratory data analysis, right? In all 8 steps. The key takeaway, the thing to remember is this. The main purpose of exploratory data analysis is to look at data before making any assumptions. If you find yourself in a situation where someone is making decisions before they've looked at the data, you know they're doing it backwards. You know they're doing it wrong. You know that the results then will be kind of a crapshoot, kind of just luck of the draw. Maybe you get lucky and you get a working AI model out of it. Maybe you don't get lucky and the model either fails or worse, appears to work, but is substantially biased, for example. And then 2 years later, you're in a massive lawsuit because you violated a number of people's civil rights. Exploratory data analysis would have helped you prevent those situations because you would have looked at the data first before making any assumptions about it. You might have spotted things like, oh, there's some protected classes in this data, like gender or race or age, and known, oh, we're going to have to, this data set's more complicated than we thought. We're going to have to be very careful on how we use it. But that's the essence of exploratory data analysis, looking at data before making any assumptions. As you embark on your own AI and machine learning projects, make sure that you do not skip this step, right? Do not skip the step of looking in the fridge before deciding what it is that you're going to cook. If you've got comments or questions about anything that we've talked about in this lecture, stop by and say hello. You can email me. You can go to the website, TrustInsights.ai. We've got a free Slack group. Go to TrustInsights.ai/analytics for marketers if you want to talk about this stuff outside of just watching this. And I thank you for being here. Thank you for your attention. And I hope that your exploratory data analysis processes reveal some really interesting stuff for you. Take care.